In this video, we're going to be looking at graphs of parabolas, specifically whether the graph opens up or down, and that's determined by the leading coefficient, whether the leading coefficient is positive or negative. We're going to be looking at the width of the parabola, and that's determined by the absolute value of the leading coefficient. The vertex of a parabola, and there's a couple of formulas for vertex of a parabola, and they're on your reference sheet. We're going to be looking at the number of x-intercepts, and that's determined by the discriminant. The formula for the discriminant is on your reference sheet. We'll look at x-intercepts and y-intercepts. And one thing I want to point out about most of the problems in this chapter is that you can always put your equation into your graphing calculator, graph it, and determine some of the answers. But for this problem, we're going to look at determining whether the graph opens up or down just by looking at the leading coefficient. Problem number 1, my leading coefficient is positive. So that means my graph is going to open up. So I know it's going to look like this. And we can, again, put that in the calculator and graph it to verify that. Problem number 2, my leading coefficient is negative. So my graph is going to open down. So it's going to look like this. The directions here say determine whether the graph is wider, narrower, or the same shape as the graph of f of x equals x squared. And again, we're going to be looking at the leading coefficient. But more specifically, we need to be looking at the absolute value of the leading coefficient. So for problem 3, I have the absolute value of negative 3/8 is equal to 3/8. And because that number is less than 1, I know that my graph is going to be wider than my original parent function of f of x equals x squared. Problem 4, I'm looking at the absolute value of 5, which is 5. And this is greater than 1. So my absolute value of my leading coefficient is greater than 1. I know my graph is going to be narrower than my parent function. Right? Because my graph here is going up about 5 times as fast, so it's going to be skinnier or more narrow. Okay. Problem 5, the absolute value of my leading coefficient is 2/7, and that number is less than 1, so my graph is going to be wider. Problem 6, the absolute value of negative 6 is positive 6, and because that is greater than 1, my graph is going to be more narrow. I'd like to also point out that you can put 2 equations into the calculator and graph both of them on the same axis. So my first graph is my parent function of x squared, and this is 3x squared. So I can see that it is more narrow than my parent function. In the next few problems, we're going to be looking at the vertex of a parabola, and so we're going to be using these formulas that are on your reference sheet. So for problem 7, I can see how the equation that I'm given lines up with my formula. H is going to be 4 and K is going to be 2. So my vertex, HK, is 4, 2. And I can always verify that by putting this function into the calculator and graphing it to see that I have the vertex at 4, 2. This equation is not in vertex form, so I'm going to be using the other formula to find the vertex of the parabola. So there's 2 steps here. First of all, we need to find the x-coordinate. And to do that, I'm going to do negative b over 2a, which is going to be negative 12 divided by 2 times 3. And that's going to give me negative 2. Once I find the x-coordinate, then I plug that back into my formula to find the y-coordinate, and that gives me negative 19. So my vertex is the point -2, -19. For problem 9, you've got a few options on how to do this problem. The easiest thing, honestly, would just be to put this in your calculator and graph it. But I want to actually use the vertex formula for this problem just because there's something unique going on with this that I think that you need to see. Actually, there's a couple of things that's unique about this problem that I think you need to see. First of all, notice that I do not have a constant added out here toward the right. I'm supposed to have a plus k to be in vertex form. So I can put +0 here, and I'm not changing the value of my function. So my k is going to be 0. But the next thing I wanted you to see is that in my formula, I have a subtraction symbol right here. And in my problem, I have an addition symbol. So I need to change what I have to subtraction. So I know that adding 6 is the same thing as subtracting -6. So now I can see that my h is going to be -6 and my k is going to be 0. So my vertex is the point -6, 0. This problem is another problem that you can work different ways using your graph or using the vertex form of the parabola or -b/2a. I'm going to rewrite this equation with my middle term as plus 0x and then do -b/2a. This will give me my x coordinate. So -0/2 times 1, that's just 0. And then I put 0 into my formula, and I get -5. So my vertex is the point 0, -5. I'm going to be using -b/2a to find the x coordinate. So this is going to give me the opposite of -3/2 times 1. And I'm just going to leave that as the fraction, 3/2. To find the y coordinate, I plug this back into my formula. So I get 7/4 for the y coordinate. And there is my vertex. With this problem, I'm going to rewrite this as 8x squared plus 0x plus 0, and then use -b/2a to find the x coordinate. Once I get the x coordinate of 0, I plug that back into my formula to find the y coordinate, and that's also 0. So my vertex is the point 0, 0. In the next set of problems, we're going to be looking at the zeros of a function. The directions say, in each problem below is the graph of a quadratic equation, degree 2. Determine the number of real zeros and imaginary zeros. Assume all real zeros are distinct. And what it means by being distinct means that you don't repeat. So like you don't have 5 as a 0 2 times. If 5 is a 0, it's only going to be appearing in your function one time. Because my quadratic equation is degree 2, I know that there are going to be 2 zeros. The number of real zeros is my number of x-intercepts. So here and here. So I have 2 real zeros. Well, if I got a total of 2 zeros and both of them are real, that means I have 0 imaginary or non-real zeros. And again, I want to stress that the number of real zeros is your number of x-intercepts, or how many places your graph crosses the x-axis. Again, I have the graph of a quadratic equation, degree 2, so I'm going to have 2 zeros. The number of real zeros are the number of x-intercepts. I do not have any x-intercepts, so there's no real zeros. That means I'm going to have 2 imaginary zeros. Now we're going to go back and talk about the discriminant again. In this table, first example that I'm looking at, I have the discriminant to be less than 0. That means my discriminant is negative. If my discriminant is negative, I'm going to have a negative under a square root, and I know that those are imaginary numbers. And that means that I'm not going to have any real zeros, so I'm going to have 0 x-intercepts. And I can see from my examples here of what my graphs could look like. I could have a graph that's opening up or down, but either way, it is not going to cross the x-axis. If my discriminant exactly equals 0, then I'm going to have the square root of 0 when I'm using the quadratic formula. And whether I have plus the square root of 0 or minus the square root of 0, I'm still going to get negative b over 2a. So I'm going to end up with only one real rational solution. So I'm going to have one x-intercept. And what I want you to notice about the graph here is that my graph just sort of sits on the x-axis. It doesn't actually cross the x-axis, just kind of hits it and then bounces back off. Now the graphs of these next two examples look the same. I am going to have 2 x-intercepts if I have 2 real solutions. Whether they're rational or irrational, I'm going to have 2 x-intercepts. In the next set of problems, we're asked to use the discriminant to determine the number of x-intercepts. And my formula for the discriminant, b squared minus 4ac, is on your reference sheet. It's also the part of the quadratic formula that is under the radical sign. So my discriminant is 81. Now if I'm looking at the quadratic formula, then what I have is something like this. I don't really care what the negative b over 2a is. If you want to put those numbers in there, that's fine. But I'm really looking at this square root. And I know that the square root of 81 is 9. So when I simplify that square root and the square roots go away, and I have a positive number here, 9, then I am going to have 2 rational solutions. And because my solutions are real, I'm going to have those zeros as x-intercepts. So I'm going to have 2 x-intercepts. And here again, I'm going to use the discriminant. So I have negative 11 for the discriminant. When I'm using that in my quadratic formula, I have the negative 11 under the radical sign. This indicates I have 2 non-real solutions. So I'm going to have 0 x-intercepts. Remember that real solutions corresponds with x-intercepts. So if I have no real solutions, I have no x-intercepts. So when I use the discriminant on this problem, I get 45. Now 45 is not a perfect square. I could simplify this if I wanted to. It would simplify to 3 times the square root of 5. But even though I simplify it, I still have a square root in here. So I have 2 irrational solutions. But irrational solutions are real solutions. So I'm going to have 2 x-intercepts. In this example, my discriminant is 0. So when I'm looking at the quadratic formula, I've got the square root of 0 which is 0. And it doesn't matter whether I add 0 or I subtract the 0. Either way, this is going to simplify to negative b over 2a. So I really only have one real solution or one rational solution. And since that rational solution is real, I'm going to have one x-intercept. And this problem says if a is greater than 0 and b squared minus 4ac equals 0, choose the corresponding graph. Okay, so if a is greater than 0, so a is positive, that means my graph is going to be opening up. So that will eliminate choice D. B squared minus 4ac equals 0. My discriminant is 0. So if I'm looking at this in my quadratic formula, I know the square root of 0 is 0. And it doesn't matter whether I add 0 or subtract it. I'm only going to have one real solution, so one x-intercept. So that leaves me with C for my answer. This example, we have A being less than 0, and my discriminant is greater than 0. I'm asked to choose the corresponding graph. If A is less than 0, so A is negative, that means my graph is going to open down. And because my discriminant is greater than 0, I know that I'm going to have real solutions, actually two real solutions. So my graph's going to open down and cross the x-axis in two places, so that is A. In this problem, I'm asked to make a sketch of the parabola where A is greater than 0, so my leading coefficient is positive, and my discriminant is less than 0, so my discriminant is negative. So A is greater than 0, A is positive, so I know that my graph is going to open up. And because my discriminant is less than 0, my discriminant is negative, that means I'm not going to have any x-intercepts. Now there's three examples of parabolas that fit my given criteria. I don't know where the vertex is. The vertex could be in quadrant 2 over here. The vertex can be right on the y-axis, or my vertex could be in quadrant 1. But all three of these options show that I have a leading coefficient that's positive. My graph is opening up. And my graph is not touching the x-axis. So I have 0 real solutions. This is a similar problem where I'm asked to make a sketch. This time my leading coefficient A is less than 0 and my discriminant's less than 0. So my graph is going to open down because my leading coefficient is negative, and I'm not going to have any x-intercepts. So here's three different options for what your graph could look like. Okay, problem 24 says to make a sketch of a parabola whose leading coefficient is positive and whose discriminant is negative. And actually, this problem is the same as the problem that we did earlier, that the directions were just written out algebraically instead of verbally. So problem 22 here is the exact same as problem 24. Problem 22 says to make a sketch of a parabola whose leading coefficient is negative and whose discriminant is 0. So the leading coefficient negative means my graph is opening down. The discriminant is 0, means I'm going to have one rational solution or one x-intercept. And that's one possible answer. The next two problems says, for the quadratic function, tell whether the graph opens up or down and whether the graph is wider, narrower, or the same shape as the graph of f of x equals x squared. Problem 26, I have a negative leading coefficient, so that means my graph is going to open down. And because the absolute value of that leading coefficient is less than 1, my graph is going to be wider. For problem 27, a positive leading coefficient, my graph is going to open up, and it's going to be narrower because it's going to go up about 3 times as fast as my parent function. Right, for the function given, we're asked to find the vertex of the parabola, determine whether the graph opens up, down, to the left, or to the right, and whether the graph is wider, narrower, or the same shape as my parent function, and finding the discriminant and using it to determine the number of x-intercepts. Okay, first thing I'm asked to do is find the vertex. Now I can put this in my calculator and graph it, and that's probably going to be fine for this problem, but not all problems are going to be as easy because sometimes you're going to have fractions for the vertex, and that graph is not going to really help you. So what I'm going to do here is use negative b over 2a to find the x-coordinate. I get negative 1. Then I'm going to find f of negative 1. That's going to give me 4, so my vertex is the point negative 1, 4. My leading coefficient is positive, so that means my graph is going to open up. And because the absolute value of that leading coefficient is greater than 1, it's going to be narrower than my parent function. The last part of this problem says, if it is a parabola with a vertical axis of symmetry, find the discriminant and use it to determine the number of x-intercepts. So I want to talk about this first part of the problem that says, if it has a vertical axis of symmetry. And it does, because those are the only types of problems that we are going to be studying in this course. So don't worry about the other types of parabolas. I have negative 48 for the discriminant. So putting negative 48 into my quadratic formula, I have negative 48 under the radical sign. That means I have non-real solutions. I actually have 2 non-real solutions. So I have 0 real solutions, so 0 x-intercepts. Here again, I'm going to find the vertex using negative b over 2a. So there's my vertex. My leading coefficient is negative, so that means my graph is going to open down. Now my leading coefficient is actually negative 1, and that's going to have the same width as the graph of my parent function. Just made the same shape here. The discriminant here is going to be 65. When I put that into my quadratic formula, I have the square root of 65. And the square root of 65 cannot be simplified. It is an irrational number. So actually what I have here are 2 irrational numbers. But irrational numbers are real. So I'm going to have 2 x-intercepts.